In today's atmosphere, let's look at the human activities and the whole atmosphere and what it's doing. This picture shows on the left the sources of all those different greenhouse gases now reported as a human activity rather than a chemical formula, showing what we do that causes the greenhouse gases to go in the atmosphere. So we'll see words like electricity and food and industry, transportation, and buildings, other things like that. That's what we put in the atmosphere as sources of the pollution. But then nature doesn't sit still. The atmosphere has its own physics and chemistry, and in fact, its own biology, because it interacts with the land and the oceans. And the atmosphere naturally removes about 40% of the greenhouse gases we put in. A little over 40% of them are almost immediately removed by nature and what we call carbon sinks, things that remove carbon dioxide from the atmosphere. This is nature. This is not us. We have not done any of this really yet. We might down the road, but so far this is almost all natural. Mainly it's in forest, on land, and biology and chemistry out in the oceans. So here's the more complete picture. We humans have about 5 or 6 big things we do that cause greenhouse gases to go in the atmosphere. Nature has 2 ways of removing it from the atmosphere, and it leaves behind around 60% of the pollution each and every year, and that's the part that stays and builds up year over year over year. And so we have to look at both sides of this equation. That is, to achieve drawdown, to stop climate change, we first need to make sure we reduce the sources, the original sources of where the pollution comes from. Those have to go to zero, not net zero. They have to go to zero in the long run. And eventually these will go to zero if we can stop climate change. Some of this will be easy. Some of this will be very, very hard. Depends on which part of it we're looking at. In the meantime, we also have to support these natural sinks that can remove some of this carbon dioxide. These arrows can get bigger or smaller quite quickly. And so we have to make sure that nature is at least removing some of these greenhouse gases so it can help stabilize and bend the curve. And maybe if we're very smart, maybe we can find ways to make these arrows bigger and add our own carbon sinks. But so far it's been all nature. So as we walk through the ideas of what do we need to do to stop climate change, starting from that science, we have to kind of work with the science and say, well, first we reduce the sources of pollution. You start from the beginning and bring emissions towards zero. So let's look at the areas we have to focus on. About 25% of greenhouse gas emissions that cause climate change are basically coming from the electricity sector, making electricity, burning coal, natural gas, and a few other things, but primarily those two, to make electricity. That's a quarter of the global emissions. Of course, each country, this mixture could be quite different, but for the globe, it's 25%. Food, agriculture, and land use, surprisingly, to some people anyway, is also about a quarter of the problem. Interestingly, making electricity and making food are roughly equal contributors to climate change, and together they cause half of the problem. Most people are a little surprised how big food is and think electricity is bigger, but food is very, very important, especially 3 or 4 areas we'll talk about in a minute. Then we have emissions from the industrial sectors, making things like concrete and steel and plastic and dealing with the world's waste streams and so on are very important. Transportation is about 15% of the emissions. Buildings are directly emitting about 6% of greenhouse gases from the buildings themselves, from things like furnaces and boilers, leaking air conditioners, and so on in the building themselves. But buildings also use a lot of the electricity that's being produced at the power plant. So a good fraction of the electricity is directed towards buildings, and buildings are made from things that are first created in industry, like concrete and steel and other materials. So the built environment actually has a much bigger footprint than this might first suggest. But buildings directly emit 6%, but indirectly it might be closer to 20, 30%. Then we have everything else, the last 10% of the emissions. A lot of that is the energy sector itself, how much energy and emissions that are linked to extracting fossil fuels or converting crude petroleum into more refined products, things like this. But the first 5 areas, electricity, food, industry, transport, and buildings, that's 90% of what causes climate change, and that's a lot. So we can start there today. Again, electricity causing about a quarter of the emissions that cause climate change today. That's very important in terms of how we produce electricity. Changing the way we make electricity can change this number a lot, but also how we use electricity, both the supply of electricity, but also how much we use altogether, whether it's made from coal or solar panels. By being more energy efficient, we can reduce the total demand for electricity, and that's another way to lower emissions. So when we at Project Drawdown look at all the possible solutions to climate change, we begin to look at the demand side and ask, how can we be more efficient with the electricity we already use? And then we look later at how we can shift production of electricity to ways to make electricity that don't release CO2. And when we do that, we look at lots and lots of individual solutions around the world, and we assess how effective they are, how large they could become, what we call the total addressable market, and also how much they cost, kind of a cost curve of the initial cost and lifetime cost of these different kind of climate solutions. Here, we're plotting for every solution we've examined so far is our estimate of how large that solution could be over the next 30 years or so. On the right, we see lots of energy efficiency solutions like better lighting, better building components, things like this. But on the left, we see ways to make electricity that don't release greenhouse gases so much, like wind, solar, nuclear, methane digesters, geothermal, biomass, all these different kinds of sources of electricity. So we look at all of these solutions together and find there's quite a lot we can do in the electricity sector. In the food and agriculture area, also linked to land use, we also see a lot of different areas for work. But it's important to know where these emissions come from. About a quarter of all the greenhouse gases come from something related to food and land use. Well, most of that comes from deforestation, clearing rainforest in particular for beef, for animal feed in the Amazon, like soybeans that are shipped around the world to feed animals. Palm oil in Indonesia, timber, other things like this are very, very destructive practices, and they emit a lot of greenhouse gases. The second big area is animal agriculture, especially methane. Methane is released from cattle and other ruminant animals that we eat for meat or for dairy products around the world. That is a big emitter of greenhouse gases and something that people need to be kind of concerned about. We also then see another big number down there of nitrous oxide, that other greenhouse gas I mentioned that comes from fertilizers and manure being used too much. There are a lot of other ones in here too, but the 3 big areas are deforestation, animal agriculture, and overusing fertilizers. Those are the 3 things in agriculture that we need to really focus on to address not only climate change, but other big environmental issues as well. And so when we look at solutions here, and I'm kind of jumping quickly to this, we both look at the ways we can reduce demand on the food system by addressing food waste and maybe shifting our diets towards more plant-rich mixtures of diets. On the left, those are the biggest things we can do in agriculture. Food waste in particular, about a third of all the food grown on the planet is never eaten. It's just thrown away and wasted. So that means a third of the land, a third of the water, a third of the greenhouse gases, a third of everything was essentially waste. If we could address some of that, that's a huge intervention in the food system that we could do that would benefit everybody. Shifting diets, we're not saying everyone in the world must be vegan or something like that. Not everybody will. And in some parts of the world, meat and dairy products are essential for culture, but also for food security in places where there may not be plant-based agriculture to rely on every year. So it's just a mixture, maybe shifting a little bit more, especially people who eat too much meat for their health, like the average American, for example. Maybe we can change that mixture somewhat. Then we look at ways to protect ecosystems from being cleared, especially ecosystems that are forest on peatlands in particular will be very important. And then shifting the way we farm altogether, managing nutrients better, growing rice better, deploying what we call regenerative practices. Those things could all be helpful to lower emissions. Later, some of these other so-called regenerative farming practices might help us create additional carbon sinks in the other part of the equation, which is kind of a nice benefit as well. But then we'll move on to other sectors. I'll go more quickly now because you kind of see the idea. If we manage both the supply and the demand of different things we do in the economy to lower emissions, we have a lot of tools at our disposal. In industry, we have to deal with many different complex parts of climate change. For example, making metals like steel, that's a pretty big area. Cement, I've mentioned before. Chemicals that we use, making plastic, that's about 1 to 2% of climate change is just tied up in plastics. We have a lot of things here that we need to address, and some of them will be very difficult. Making low carbon steel and concrete could be very challenging, maybe harder than some other things that we need to do, but we have to do them in the long run. Then we get to transportation. That's 14% in total of our emissions. Most of that's in roads, about 10 of that 14%, but aviation is also very important, especially from an equity point of view. A very small number of people are causing that 2% of global emissions, as some people fly a lot more than others. We have to think about that too. Then we get to buildings. In addition to the emissions from electricity that goes to buildings or building materials or made in industry, buildings operations directly emit 6% of greenhouse gases from heating, hot water, leaking air conditioners, and so on. Most of that's in residential buildings. Some of that's in new commercial buildings as well. So these are things we all have to look at. The bottom line is we have a lot of different areas of greenhouse gas sources. It's not just a power plant. It's not just a hamburger. It's not just a car. It's hundreds of things, and we need to look at them all together. But there are some overarching lessons of being more efficient and transitioning to low carbon alternatives. We have a lot of those opportunities. We also can look at the other side of the equation on the carbon sinks that we need to look at. Sometimes this is called carbon removal. I do want to stress, though, because right now in the news, in the media, there's a lot of attention, I would call it hype, a lot of over attention to what we call to carbon removal, especially technology-based carbon removal. But basically, nature is doing 100% of this so far. All of the machines, all of the factories are supposedly removing carbon from the atmosphere are like 1/1,000,000th the size we need compared to what forests do. They're not even a round-off error yet. So basically, this is just nature. Nature does this in forest, so we have to protect forests. Nature does this in wetlands. We have to protect wetlands. We could do this in agriculture if we farm differently. So how we protect and manage land will be critical. Coastal and ocean ecosystems also absorb carbon, so protecting and managing coastal ecosystems and some of the open ocean is also critical. So that'll be very important. Lastly, yes, maybe someday, 20, 30 years from now, we'll have machines that can actually absorb meaningful amounts of carbon from the atmosphere. But today they're so trivial, I'm not very excited about them. And they've been around a very long time, and this technology isn't really changing very much. Mainly it's big fans blowing air through chemical solvents. We've been doing that since the 1950s, and mainly in the oil and gas industry, using that carbon dioxide and pumping it underground to extract more oil and gas. So this is getting a lot of attention in the media and from government officials and venture capital, but it's not really real yet. So be a little bit careful about these claims. They're very, very small. Finally, we've looked at things to reduce greenhouse gases, ways to work with nature to enhance carbon removal in nature. A third area, though I haven't mentioned yet, is a very nice kind of surprise. As it turns out, when we do other things around the world that aren't related to climate change directly, like improving access to education and healthcare, especially for women and girls, or helping indigenous communities protect their land and their land tenure and their forest, and many other things we should do for improving the human condition, we find that those often set off a chain of events that can lead to other climate benefits as well. For example, changing future demography or indigenous cultures when they protect their forest, those forests tend to absorb and store more carbon than the forest of their neighbors. And so we find that kind of human-centered solutions for human rights and human well-being can also trigger climate solutions. And so I want to put all this together into one kind of big picture where climate solutions will never be found in just one place. But if we put together several different ways to reduce the sources of greenhouse gases in electricity, in food, in industry, transportation, buildings, and so on, and we show how we can work with nature, protecting it, but also maybe augmenting it, land and oceans, and perhaps down the road with some machines, and things that are we do that help human well-being around the world directly through human rights, education, health, and so on, we find that we have a whole constellation of solutions that can work together to change the future and make it better. Here are some examples. If we take all the solutions that we at Drawdown have analyzed, and again, these are all existing solutions that are here today. None of these are waiting for science or engineering to be developed. They're here now. They're available today. We can stop climate change with tools we have right now. Even if we invented nothing new, we could actually still stop climate change. Now, of course, if we invent more technologies and more practices, that'll help, but we don't have to wait. We have everything we need to get started now, and it only will get better as we develop additional tools. But even with the tools we have now, we can change the future. The red curve shows what would probably happen to the atmosphere if we stick to our current path of greenhouse gas emissions, but we don't have to. We could choose this red curve or this green curve that managed to stop climate change as early as the mid-2040s, still another 25 to 30 years of hard work, or through the 2050s or 2060s. In fact, every curve between the green one and the red one, everything in that space is possible. But we're illustrating two possible paths that are pretty aggressive, but they could stop climate change in the 2040s through the 2060s. And that would allow us to limit the warming of our planet. We're already a little bit over 1 degree Celsius, and it's continuing to rise quickly. We could stop it maybe at 1.5 degrees if we act very quickly and aggressively, and perhaps less than 2 degrees in other scenarios. But if we don't do that, we continue on the path we're on now, we're going to head past 3, 4 other degrees, which would be a radical amount of damage to this planet and a world we wouldn't even recognize. So we don't want to go there. So what we've learned so far from this basic exercise is that even with today's technologies, with our tools right now, it is not too late to stop climate change. We have enough to stop it now, and it's only going to get better. In addition, we find that almost all of these solutions make almost everyone in the world better off economically, but also in terms of health and human rights and equity and diversity and all the other things we care about. This is a chance to kind of rethink how we make and use energy, how we have cities, how we transport ourselves around the world, or how we produce our food, how we live together, how we relate. All of these things could be done better. All of the solutions we're proposing don't require big sacrifices, unless maybe you're the CEO of a big oil company or something, but the rest of us will be far better off and could be also a great opportunity to improve the health and equity of peoples around the world. So this is actually a really, really good thing to do. The big challenge, though, is time. We have the tools. We've been dragging our feet doing anything about this, largely due to very powerful people slowing down that conversation for decades. And now we have to catch up. We have to very quickly deploy these solutions very, very quickly in order to avert the worst sets of climate change. The red curve kind of shows up to 2020, where that dot is, the greenhouse gas emissions we've seen so far. And what we have to do is now lower them dramatically, like cutting them in half in the next decade or so, half again in the 2030s, and half again in the 2040s. And then during that later time in the 2040s and 2050s, we can maybe scale up some of that carbon removal to take out some of the last emissions we don't know how to remove at that point. And that's how we'll get to kind of stopping climate change by around 2050s or so. To do that, though, we need some quick wins right now that have dramatic effects on lowering emissions. Things like stopping deforestation, energy efficiency, plugging leaks in methane, reducing food waste, stopping the flaring of natural gas. Things like this would be very immediate wins on climate change we could do very quickly and see kind of immediate impacts in the atmosphere. A lot of the other work we need to begin right now, today, is around infrastructure, changing our energy systems, our transportation systems, our buildings, our agriculture. All of those things need to be kind of rethought in ways that can be much better for climate change. We should have been doing this starting in the 1980s or earlier, and now we have to catch up and dramatically kind of rebuild the whole world. But hopefully we can do that, and also it will be a chance to do a lot of other things better while we're at it. In the meantime, longer term, we can be planting forest, maybe changing the way we do agriculture, restoring wetlands, other things to help kind of heal nature, regenerative practices. These are really important, but they naturally take a few decades to start sucking up carbon and putting it back into trees and soil and wetlands and other things. We can't count on that to stop greenhouse gases today, but if we plant these seeds now, literally and figuratively, they can help us in future decades absorb some of our greenhouse gases. That, of course, new technologies will come along, some things that are, we hope to have in the future, but we need to keep working on them now. Those might come up to bear in the 2030s, 2040s, and 2050s, knowing it sometimes takes a few decades for these technologies to truly scale to the globe. And this is kind of what we need to do. Some immediate things, a lot of work on infrastructure, work with nature, and continue to do research and development, all at the same time. Now, this does look like a big challenge, of course, and it is. And if we get it wrong, or if we ignore it, we're going to be in a lot of trouble. But I also like to think of the other side of this, not only how big the problem is, but how big the opportunity is. Because we not only have to reimagine everything in the world, we get to. That's really exciting, actually. We get to reimagine how we create energy and use it around the world. We get to reimagine our cities and communities. We get to reimagine the food system, because all of these systems are actually quite broken. Even if it's not around climate change, a lot of issues around equity and justice and health and security, the economy, are not working very well today. We're all basing all this stuff on kind of 19th century or early 20th century thinking. That won't help us very much in the 21st and 22nd century. So we need to rethink all of these things and do them better. And frankly, I think this is a better way to run a world. When we stop climate change in the future, we're going to look back and ask, why did this take us so long? This is great. We're living in a better world with more equity, more health, more security, more justice, and more health, more prosperity and kindness and human well-being than we've ever had before. And we stopped climate change. This is great. Why didn't we do this earlier? So this is what I'd like to do, is to wrap up now and say, my ask now of you is to, we need all of us to participate in solving this problem. Of course, the best place to begin for all of us is to continue to learn and from each other and share with each other everything we know. No one person or organization has all the answers to this kind of problem. So we have to continue to learn and share as we go from everyone. I hope our organization can be helpful. Please follow us at drawdown.org or Project Drawdown on social media. But most of all, I hope people will exercise their own leadership wherever they are, in policy, in business, in academia, in communities, in spiritual communities, in every school, every town, everywhere around the world. How can we be leaders wherever we are and making a better world around us in small ways and in big ways? But finally, the big thing I think here is to always remember that the future is still ours to write. Robert Anton Wilson has this wonderful quote where he reminds us, the future is up for grabs. It belongs to any and all who will take the risk and accept the responsibility of consciously creating a future they want. So I hope that's something we can maybe begin to do together, is build a better future for those of us, today, but also everyone who will come after us in the future. So with that, I'll just stop here and say thank you, and we'll turn over to questions and conversation, I hope. But thanks very much for having me here today. I really appreciate it. Thank you.
Thank you, John. Thank you for that very comprehensive and insightful presentation. And more importantly, if I might add, uh, unlike other climate change talks, not very gloomy and doomsday scenario that actually giving a sense of uh, hope and responsibility on part of individuals. Again, folks, if you have questions, feel free to put it in the chat box so we can get to it. Uh, uh, One of the things that sort of struck me in one of your earlier slides, where you present that when the population grew twice as much, the consumption grew 3 times as much.
Mm.
What do you attribute that to? Because one of the challenges through all the slides is the challenge of human consumption,
Yeah.
which is a behavioral issue in many respects. But why do you think that suddenly at that point in time we began to consume more, and we are still in that sort of market economy that is mostly driven by encouraging the appetite for consumption?
Yeah, exactly. That's one of the things that's so important, is that, yes, the number of people on Earth matters, of course. There's always going to be that argument, but population grew a certain amount and it's slowing down very quickly. Population growth is falling faster than anyone ever thought. And most of the population growth is in places that aren't consuming very much anyway. So the idea that population growth is a big driver of environmental harm is not true. It's mostly disproportionately around consumption. And so, yes, kind of a consumer-oriented capitalist system has grown. It's kind of been an economic miracle, but it comes with a lot of harm, a lot of overconsumption, a lot of human rights issues, a lot of injustices that are being created. And of course, this is more your side of the street, but a lot of, kind of think people chasing stuff instead of themselves and improving themselves, just buying more things to comfort themselves in the short run. And that's a fairly shallow life. So we need to do better. But I think the years of environmentalists just saying stop consuming, that's not very realistic. To just say stop, but could we be more mindful, be better? And I have no problem with people like consuming more music or more free time or more time with people they love or enjoying meals together and things like that. That seems lovely. And to have comfortable places to live and hang out and things to wear and all that's nice, but we have to decouple that from destroying the planet. Can we be living good and rich and full lives with materials and things that we like? Sure, we can do that, but we cannot do it at the expense of future generations and a limited physical planet, of course. So that's going to be a lot of the work ahead, is to decouple the economic kind of throughput of the economy. We can have goods and services without emitting carbon. But do we really need all this crap? Can we at least cut out some of the really stupid things, especially those that are very harmful? So I like to think about when we look at the economy, can we ask the question, what does this provide a net improvement in human well-being divided by the net harm it might do to the planet and future generations? And just ask really hard questions. Like, do we really need to do this, given that it's not helping us that much and it causes a lot of harm? But there are other things where, hey, we enjoy that and it's good for us and we like it, and it doesn't have to do as much harm. We could do it better. So it's probably going to be a lot of nudging, but shutting down the global economy is probably not going to happen. And capitalism per se isn't necessarily worse than a planned economy. The planned economies of the world weren't very good for the environment either. So there might be something more fundamental in human nature that we need to tackle than just pointing fingers at capitalism per se. It's probably more than that. But this is, again, an area you think about a lot. So
what would you think if we were to, there are all these efforts now on part of UN and other groups to sort of move our focus again from just looking at GDP as a growth metric and things like that. As a climate scientist, what would you suggest ought to be our focus when we think about progress and growth? Are all kinds of progress and growth good? Or should there be other variables that we should be looking at it?
Well, that's a very big question. And I think everyone in the room would have thoughts on this. Scientists I work with, though, from our more narrow lens of looking at kind of the economy from a kind of an environmental perspective, there's been a lot of writing about what's called a natural capital, saying there's financial capital, human capital, physical capital. Those are all things economists measure. But nature has capital stocks as well. A wealthy people would also be asking about not just the pile of money in the world, but also how healthy are people, and social capital, but also natural capital, like how much clean water do we have? Are the forests increasing or are they decreasing? Are we polluting more, every year, or are we polluting less every year? So I think that's, a more enlightened version of a capitalist mindset would look at all the stocks of capital, not just piles of dollars, but human well-being. Are people living longer, healthier, happier, more full lives? That would matter to me. But also in nature, do we have more forests than before, and more fish, and cleaner air, and cleaner water, and a not disturbed climate? That to me would be a truer sign of wealth, as something we could build and pass on to future generations, just like generations before us tried to do at their best. So yeah, I think, but if all we do is build a pile of plastic and a pile of money, or a pile of Bitcoin or whatever the heck, and we deplete all these other stocks of people's well-being and nature and our future and mind it, that's not capitalism, that's profiteering. And that's not something that works well in the long run. It's just kind of stealing from nature and from the future.
One of the confusions sometimes, in at least developing economies, is about the role of nuclear energy. Just sort of the lens with which they look at nuclear energy, and then of course in light of the Fukushima plants and so on. But on a scale of energy consumption and energy production, with regards to, say, fossil fuels versus nuclear energy versus other things, how would you place it, and what would you suggest to developing countries who are trying to actually avoid sometimes the idea of nuclear energy?
Well, yeah, nuclear is very interesting because on one, there are pluses and minuses to all of these things. On the plus side of the column, nuclear energy is, we do know how to do it. It's been proven and fairly reliable in some ways. And it's something that can produce, a lot of electrical power, and is, virtually carbon free. So there are some benefits to nuclear energy that are obvious. The detriments are also obvious, that, maybe it's safe most of the time, probably safer in some ways than other forms of energy, but when it's not safe, it can be catastrophic. And that's a bad thing. And perhaps these disasters get more attention than the equivalent disasters of oil and gas. People in the nuclear industry argue that they get beat up more than others, but wow, when they screw up, it's bad. It's really bad. So, and then you have the waste problem of, like, nobody's really answered what do we do long term with these nuclear waste issues. But then in the near term, there's also the pragmatic issue of, can you really build nuclear power at scale? Why is it getting more expensive? It's the only form of energy on Earth that has gotten more expensive over time, where solar, wind, and other things have gotten far cheaper. Nuclear has gotten more expensive, and you can't blame the environmentalists for that. It's actually just construction costs have gone up, red tape. And nuclear, when you build a nuclear power plant, it's a multi-billion-dollar one-off project designed for that particular place. There's no what we call a learning curve. When you make millions of solar panels that are identical, after you made the first one, they all get cheaper. The more you make, the cheaper it gets. Nuclear doesn't have that same learning curve. It seems to get more expensive. So I guess in rich countries like, the US and in Europe, I don't think you're going to see another nuclear power plant built in America ever again. Not just because of environmental activists, mostly because of economics. Who would invest in it? Who would insure it? Who would actually propose it? Nobody. The private markets don't want to touch it. Similarly with Europe, Japan, other places, it's really a question mark will be China and Russia, probably, what they do. Probably China will continue to build more nuclear, and they can. They probably will. In the United States, I would say it's going to be more about keeping our existing nuclear fleet operating a little bit longer past its earlier lifetime until we can replace it with better storage and better renewables. But if I were, it depends on the situation, but I think I would probably lean towards advising invest in renewables and better storage, because those have much more efficient learning curves. The more we build, the cheaper they get. They're not without environmental harms too, though. Batteries, as we all know, lithium and cobalt and other things in our batteries, which we already build a lot of, even before renewable energy and before electric cars and all this. We have a lot of these things filled with batteries and our laptops and all this. So we'll have a battery problem even if we don't attack climate change that we have to solve. But fortunately, I think that's a problem we can solve. Nuclear, we don't know how to solve that. Lithium, I think we do. We're just being too cheap and too greedy to do it so far, but we can do it. With nuclear, I'm not sure we know how. So, these are all complicated issues. There's no free lunch, but renewables and energy storage, I think, is the least disruptive path and the one we can learn the most from the most quickly as we move forward.
Speaking of free lunch, I remember one of our earlier conversations on food security, where you had actually suggested that, yes, the population boom is a challenge, but it's not that much of a challenge. That the bigger challenge, as you reminded us today, is the food waste issue. Are there enterprises or organizations in your mind that are actively working on combating the food distribution and waste issue for more equitable distributions?
Not nearly enough. I think food waste is one of the biggest, most shameful environmental problems we have, because it's so obvious, and yet we've done very little about it. I'd like to see a lot more technology. I'd like to see more venture capital, more policy, more business focusing on food waste. It's kind of this giant problem that we all kind of overlook. And because it's messy, it happens a little bit everywhere. Some of it happens in richer countries. It happens in our own kitchens, in restaurants and businesses and cafeterias and markets. But in poor countries, it's a little bit worse because it happens closer to the farmer because of poor infrastructure. The crop maybe never got sold, so you lost the food, and a poor farmer lost their income. And so it's kind of the double tragedy there. What can we do to improve loss from the field to our plate? And every step of that journey, are there technological innovations, more policy, more awareness and culture? A little bit of all the above. And but it isn't going to be one savior technology. Elon Musk doesn't have an app for this yet, or something. It's not that simple a problem. It's a more nuanced, distributed problem, but it's enormous of all the things we could do in the food system, not only for climate change, but for biodiversity and helping poor people have more to drive down food prices and have more food available during shocks. It would help disproportionately help the world's poor and food security and nutrition, but also a dramatic help for climate change, biodiversity, water, everything. So, it's kind of the biggest and dumbest environmental problem we have, and yet we've made fairly little progress. There has been, though, at the local level, I think, some excellent efforts in different countries to reduce food waste. But I think, we need to learn from those and emulate those and fund these and put a lot more effort behind them to make them in every community, not just a few.
Well, thank you, John. One of the things that we are hearing more of in the climate conversation is feedback loops and how it's sort of contributing to a greater sense of urgency. Mm-hmm. Could you enlighten us a bit more about what feedback loops are and our role in that and so on?
Yeah, climate scientists have always been thinking about this kind of thing. The idea is that the Earth is a very dynamic system, that when we add greenhouse gases and warm the Earth responds and does something else. And sometimes what it does might counteract the warming that we caused initially. That would be good. But sometimes it takes the warming we caused initially and makes it even bigger than it was before. The prime example of that is when we warm the planet, it melts snow and melts ice in the Arctic and in the mountains. Well, when you take something that's bright and white, covered with snow and ice, that reflects the sun's radiation, the heat from the sun, making something cooler than before. If you melt the Arctic, making a bright white surface dark and blue, it actually absorbs more heat and warms even further. That's why the Arctic Ocean and the far north of the planet is warming at 3 times the rate the rest of the world is. And climate scientists have known this for 100 years, and all of the models we have include those feedback loops that kind of that nature provides. But there are worries that there might be additional ones. Things like as the planet warms, it might start to melt things like permafrost in the Arctic, and that could release more carbon into the atmosphere. Yes, over thousands of years that will happen, maybe. And we kind of have a pretty good idea how much they'll happen. Those have already been thought through pretty carefully, but again, the science could be off. We need to be careful and keep watching these things. So those do worry us a lot. But in the media, sometimes we hear about like tipping points where, oh my God, it's just, now it's a chain of events that will unfold and the Earth will tip into some catastrophic holocaust of the environment tomorrow. That's actually not true. A lot of those are over hyped, they're exaggerated by earnest reporters looking for one more click on their website, or an editor putting a crazy headline, an article that might otherwise be good. So just be very careful there and talk to the scientists who actually work in this field. We do know about this stuff. We've been watching for it for years, and there are a lot of us who've been monitoring the planet for 30, 40, 50 years. It's, there are things that worry us, but nothing so far that's been a giant surprise, but they are worrying. The warmer the planet gets, the warmer the planet can get. But it doesn't mean a runaway thing. We can still slow it down and stop it. That is still within our power. But if we get to 2, 3, 4 degrees warmer than normal, all bets are off. That's getting into a planet we don't have experience with. But below about 2 degrees, we think if we stop climate change between 1.5 to 2 degrees, it would be bad, but not fatally catastrophic. It may be something we can live with. But more than that, it's scientists are like, we don't know. It would be a whole different world than Earth. And I don't think we want to do that experiment.
Hopefully not, although can't trust the scientific instinct with the kinds of experiments we want to do these days.
This is true. Fair enough.
A question from the audience. What does the future of science education for younger learners, students look like in this dynamic environment? What are the opportunities for this audience to engage with solutions?
Oh, that's a great question. I mean, I have a particular bias as a scientist, and also somebody who cares a lot about science education. Clearly, science is not enough to make a good world, but I do think it's an essential pillar. We got into this mess because we didn't listen to science. Science is a toolbox to look at the world and try to understand our own biases. We test our assumptions against nature, against empirical evidence, against data, and sometimes we find out we're wrong, and that's good. It challenges us to think differently. But it's a human enterprise. We make a lot of mistakes in science. It's as flawed as we are as people, naturally. But at least has a built-in correction mechanism to try to keep us from being fooled all the time. So I think it's really important for everyone to have good, strong scientific literacy. I worry about the lack of rigor in people's education today. I think we're getting too soft. Young people today don't learn math. They don't learn science the way I think they should. But we have to learn so many other things too, to make people kind and just and more equitable and wise, not just smart on math and science. So that's why I love this center at a place like MIT to bring, pretty smart students, but also to ask them to think of something more than just kind of the equations and the data. So I think science education needs to be more about the whole person, but I still believe a bedrock of rigorous mathematics and science is essential for a lot of people, and a good scientific literacy is important for everyone, but combined with, a sense of like ethics. I wish everyone in the world were well schooled in physics and ethics, so we know what the world does and then what we should do. Would be a kind of a nice pairing of education. But I do worry about that a little bit. But also how to move away from just describing a problem. It's very easy to describe problems and be a critic than to offer solutions. And I think a lot of our education in general, not only the sciences, but especially the social sciences, are very good to critique others, but then to offer solutions. they're like, well, that's great that you think this is bad. Now, what do we actually do? It'd be like a doctor coming to you like, wow, you're really sick, but I'm out of here. I'm bye. It just walks out the door. That'd be a very poor physician. We need to offer care and solutions and help, but also, sorry, it's a long-winded answer, more solutions, less hubris, more rigor, but more empathy. Kind of, I think there's a kind of a degree of sophistication in our thinking that could be both more scientifically rigorous, but also more spiritually, I don't know, with more empathy and kindness, and offering help to the world rather than just critique and snark. Things like this would be very helpful.
Well, definitely, I think the world can do with less cynicism and less snark.
Yeah.
In our times. In the interest of time, John, perhaps just one last question.
Sure.
What personally gives you hope?
Well, I won't be the first to say this, of course. I'm sure others have said this better than me. There's a wonderful book called Hope in the Dark by Rebecca Solnit I'd recommend to people. We do live in a challenging time, so hope is sometimes elusive some days. But I remember hope is a verb. It's not a noun. It's not something you just find. It's not, hope is not the same as optimism. Optimism is like a belief that it'll just be fine. If I don't need to do anything, somehow it'll turn out okay. I don't have a lot of that. But if hope is saying, no, it's a passionate belief that if we try, that makes we have to try, that we should put everything on the line, like our lives, our dreams, our love, our passion, everything out of there, and we still might fail. Hope is a crystal clear vision that, maybe we won't succeed, but damn it, we're going to try. And I think it's as close to love as a verb that I can think of. That, if we truly love others and the people we've even yet to meet in the world that might live in the future, the best thing we can do as humans is offer them our hope, which means our blood, our sweat, our tears, our time, our work, everything, and our love. I know that sounds strange as a scientist to say that, but I really do believe this, that, hope must be an active stance, risking it all, doing everything we can to build a better world. And we still may fail, but if we don't, who are we? If we don't even try. So again, hope as a verb, I try to find, and I find it in nature, this incredible, beautiful planet we live on that's so miraculous. And I sometimes see it in other people who inspire us. And also, I have children and now a grandson, and those things give me hope, or at least fuel my hope, I should say. But yeah, again, don't confuse that with blind optimism or a passive belief that everything will just be okay if you sit on the sidelines, because it won't. But hope, if it gets you up in the morning, it gets you working hard and learning to risk it all for a better world, then I think we've got a good chance.
Great. John, thank you so very much again for joining us this morning and for this illuminating talk and conversation. And for those in the audience, do take a look at Project Drawdown website, see what you can do in your part, in your leadership roles to offer solutions and be a multiplier effect. And I know some of you have asked about videos of the talks and so on. We'll gradually make it available on the website, and you will hear about it through emails. And also look forward to the announcement for another REIMAGINE series in the fall. So thank you all for joining us. Jonathan, thank you so very much. And look forward to continuing the conversation.
Thank you. Cheers.